platform isn't just XPU, it's not just compute.
Right.
What are the talk a little bit about what the platforms look like beyond just the, fighting for those, those custom AI chips?
Sure. So if you think about the space, one XPU GPU is not good enough for anything. You can't build the application to fit into one XPU or GPU. So you have to string together thousands, tens of thousands of them. And so that means we fundamentally have a connectivity problem. How do you actually build these at data center scale? And so ultimately what that really means is there's a platform around them. If you start with the basics of an XPU, the best thing you can do is pack as many transistors as you possibly can into one reticle sized die. Not enough. So then you go with advanced packaging, and Marvell's made numerous announcements on this subject over the past few months, and you package multiple of these die together with high bandwidth memory into a single package. Then you want to put as many of those on a board as you can, put as many of those in a rack as you can, put as many racks in a data center as you can, and connect all of them with as much bandwidth and connectivity as you can to really build out a logical XPU, if you will, out of multiple smaller components. And so ultimately, the way that is done tends to be tied very closely to the architecture. So if you built a custom XPU, you probably have a custom platform. You're not just using a standard off-the-shelf platform. Now, that is a change. When this first started, you probably did. Just put it into a standard like x86 infrastructure with a top-of-rack switch that was running Ethernet and all of these other pieces. But that infrastructure moves at a much slower pace. And so what you're seeing now is an investment in building new types of custom scale-up fabrics and the rest of the platform going custom to be able to really get as much of this compute power available as possible, optimized and designed for your application.
So it's interesting though, because as we pin it at something like 10% right now, XPU versus kind of the big GPU spend. But it is converging. It's closing in because the volume buying, the diversification. But when you talk about the overall platforms, one of the big rate limiters, Chris, is going to be the network. So you're very focused on interconnect as well. AI doesn't function all that well if you can't move the data quick enough. So you hear a lot about scale up, you hear a lot about scale out. Marvell has a pretty significant role to play there as well. I mean, how fast are you seeing the industry keep up from this space of connecting everything as we are spending time talking about doubling and tripling, an exponential growth of compute power?
On every one of these vectors, I continue to be amazed. If you start in packaging today has achieved things that nobody's ever thought of before. And ultimately being able to package the number of die and the size of these it's hard to call them chips. These things are like, 6 inches by 6 inches. These are huge packages. And so that's one technology vector. The next technology vector is, of course, how do you actually connect them together with the high-speed copper interconnect? And there's tons of innovation there. Eventually, you're going to run out of space there, and it's going to need to go optical. So we've made announcements around our co-packaged optics solutions to be able to build an any-to-any XPU fabric, all optically connected straight into the package. That's a new innovation that's coming as well. And of course, once you build out that rack and you have the rack scale platform, now you need to be able to go across the data center and build as many as you can there. And Marvell demonstrated the world's first 448 gig PAM4 optical connectivity at OFC a couple of months ago. A few years ago, there was debate in the industry whether you could ever do 448. In the technology industry, we sometimes think we'll never be able to go beyond this. There's some barrier coming. And I'm always amazed at the ingenuity of engineers to break through that barrier. And another one is the reach of PAM4. These data centers are now getting so big that it's starting to hit the end of that. And so between data center, the ZR space for data center interconnect is too high a power. The PAM is too short a distance. So Marvell announced the first coherent light solution that actually takes and combines parts of both technology that allows you to connect huge campus-wide data centers. So if you look at every one of these vectors, the race is on, the engineers are innovating, and the technology is moving at a pace unlike anything we've ever seen.